All right, so here we want to find null A and column A for this matrix A. All right, so I put it into my calculator. Do note I had to add in 2 columns of zeros to not get a syntax error. So it doesn't make any difference, but for some reason it just likes to have different dimensions. So make sure you just put in 2 columns of zeros, and then you can do RREF on this and you get this. All right, so to find column A, remember column A is the easier of the two. So column A is then it's going to be the pivot columns. So that's going to be the first column. So remember, you have to go back to the original matrix. So that's the basis for column A, correct? That's the one vector that spans, it's linearly independent. So this is the basis. I guess I should have said basis for column A. So the basis for column A is this. Okay, so now let's find the basis for null A. So how do you find null A? That's where you're going to set this equal to, or augment this with the 0 matrix, so then, or the 0 column. So then this first row gives us x sub 1 minus 2/3 x sub 2 equals 0. So x sub 1 is 2/3 x sub 2. So thinking about what the domain vectors are, right? This is a 4×2 matrix, so it would be multiplied by a 2×1, and since there's just 2 columns, x1, x2, my solution, x1, x2 to ax equals 0 will be from the domain, right? So this is going to be 2/3 x2, x2, so x2, 2/3, 1. So then the basis for null A will be this vector. I could use the vector 2/3, 1, or I could say 2, 3, right? By multiplying, since it's a basis vector, I can multiply it by, or it's a free variable, I could just put this x sub 2 equals 3, right? Can't always do that, but when you've got a vector that spans a solution set, that's when you can do it. So if I want to find one non-zero vector in null A, I could say, whoops, I'm going to say make a fraction there, 2, 3, or -2, -3, right? Any linear combination or multiple of this vector or this vector. So a vector in column A, you could use just the opposite of this vector here. So -6, 3, 9, -9. So 2 different kinds of vectors, right? So in the domain is R2, right? And then the codomain is R4. So the domain vectors and then the codomain vectors.